Thank you. Thanks, everyone. So when we talk about consciousness, we should probably first of all try to agree on what it is that you're pointing at. And when we introspectively refer to consciousness, what I think we mean by it is first of all second-order perception. It's not just that there is contents available, but we notice that these contents are available. We basically model of what it would be like when something was receiving this content. And it's also, we know, when consciousness is happening, it's always happening now. It creates the sense of, this is happening now, this is presence, this is the present, there's something happening to me. And the third aspect is one that is somewhat facultative. It's the sense of being something and looking into the world from this perspective. It's basically inhabiting the surface of a self-world. But you don't have to do that to be conscious. You can also be conscious in dreams, for instance, at night, and there's sometimes nobody there to witness this stuff happening. And so you might have only this awareness of events. So this is not really a definition, it's more like pointing at a certain phenomenon, which we call the phenomenology of consciousness. And when we want to explain it, I think we have to capture this phenomenology. As the other side is the functionality of consciousness. This is basically the wires and pulleys behind it, the mechanisms that make it happen. And I suspect that consciousness is a mechanism to create coherence in the mind. And it's basically a machine learning algorithm for a self-organizing system. What we observe in human beings is that they all are conscious. It's really interesting, right? It's not something that we get to be at the end of our PhD is the pinnacle of extremely complicated mental development. We get there before we can track a finger. And this suggests that we also observe the fact that human beings, when they don't manage to become conscious and they don't manage to wake up as infants, they remain persistently in a vegetative state. They don't get anywhere. And so consciousness seems to come first, not last. It seems to be not the result of extremely complicated mental organization, but it's prerequisite. And when we observe in biology that basically every complicated animal that we can make sense of is conscious. There's nothing simpler. There's no alternative. If there was something simpler, more alternative, evolution would, in a number of cases, converge on that simpler solution, and you should observe people which can do the same things as us without being conscious. And so I suspect it's actually the simplest way to train a human brain into the state that it is in. And when we look at it from another functional perspective, it is a projection of our working memory states at any one time into something that can be used as a protocol, so you can later call it up as a stream of consciousness. And it's something that you find, for instance, reflected, I think, in a slightly confusing way in the global workspace theory by Bernard Bars. There's this idea of a spotlight that is somehow going over the integrated working memory contents. And I think of AI as a philosophical project. 99% of AI is just making data processing more efficient, but 1% of it is this philosophical project. And a lot of confusion comes because people think it's the same, one or the other, but there's slightly different aspects of this field. And I think it's currently the best way to make progress on this question, what minds are, how they realize the nature. And AI is basically bringing perspectives from control theory together and with the theory of representation. And it's a tradition of thoughts that AI is building on, and this tradition begins in many ways with Aristotle, and then in the modern times with Leibniz and Frege, who thought about the nature of languages, and Helmholtz, who thought about the physics of psychology, Tarski, who thinks about how to formalize Frege's ideas of how to make a language for thought more systematically, Wittgenstein, who had this idea to turn English into some kind of programming language so you can say true things in it. And then basically preempted Minsky's project by 30 years and also failed 30 years before Minsky at the end of his life for maybe similar reasons. And then you basically see this line continuing into the present. And when you look at Aristotle, he is in many ways a very modern thinker. And Christians turned him into some kind of dogmatic figure. But when you read him, you find that he is very approachable. He's really a guy walking through those thoughts and collecting all the ideas. He's very much like a young modern explorer, and he is willing to argue with you. He's willing to take steps back. He can give counter-arguments to the manual weekends. It's very refreshing to read. Also, he was super successful. Maybe some of you know that he was the teacher of Alexander the Great, who went on to become an extremely successful civilization builder and conqueror and politician. And so there's very polymath. And he, when he describes things in nature, he says that the soul is extremely important. It's the animated principle basically on nature. He calls it basically dynamic form that is printed on the physical universe and shapes it in causal form. And the soul is something that you find everywhere in nature. Wherever you find complex structure in nature, like in ecosystems or plants and so on, you have something like the soul. But the reason, nous, is something, intellect, that only humans have, because it does require symbolic reflection, grammatical language, and so on. And when you look at his text, he really comes up with a number of categories in regards to perception, sensory images, that sensor data, image recognition processes, geometric shapes, graphs, generated AI in a way, sensory reproduction, multimodal scene interpretation, is advanced terms for all of these things. And it's very modern, and a lot of the philosophers who read this later tried to map this into their own much less technical way of looking at things, and often mistranslate the terms or merge them in weird ways where the terms don't actually do the work that Aristotle envisioned for them. But when you read this as a modern cognitive scientist or AI researcher, this is one of us. This guy would have killed for having a computer and trying things. And it's very interesting that consciousness is not mysterious to him. He calls it actuality usually, and he doesn't seem to have a hard problem. And I suspect that this hard problem of consciousness that David Chan was famously branded as the thing that made him famous, is something that happens after the Enlightenment, a bit after the Renaissance, but outside of this culture it doesn't seem to be a big issue. And the Western philosophers basically despair about consciousness, and they came to a number of divergent positions, like dualism, the idea that mind and matter are completely separate things, and this interaction between is very flawed because the definition calls it closed. Then idealism, which means everything is mind. Panpsychism is that mind is an aspect of matter that is distributed everywhere where matter is. Materialism says that everything is just matter and mechanisms. And identity theory says that mental processes are exactly the same thing as brain processes. Then there is the integrated information theory, which is in some sense the control group. If somebody doesn't see that it's a violation of the Turing thesis, then they should not be in the room. Illusionism is the idea that there is no consciousness at all. We only need to explain why some people claim to have it. Mysterianism is the theory that something that consciousness cannot be understood if Noam Chomsky cannot understand it. Noam Chomsky is a Mysterianist. And so all these theories, basically, they give arguments either for why consciousness cannot be understood by us, or why it's in principle impossible to understand consciousness because the terminology and the concepts are built in such a way that there is no solution. On the other hand, there are complementary and conversion positions in philosophy and in cognitive science. One is functionalism, the idea that, like everything else that we construct as a meaningful object, consciousness is some kind of behavior, some way in which reality changes under particular circumstances, some invariance that you can discover there. Representationalism is the idea that consciousness is some kind of representation, some kind of causal pattern that itself is not identical to a physical process, but it's something that can involve physical processes. The attention schema theory by Marciano is that it's similar to our body schema being a model of our body in space. Consciousness is a model of our attention in the mind and in the world. And global workspace theory is this idea that consciousness is the localized projection of your working memory contents, and we have Rosberg's adaptive resonance theory, which says it's some kind of oscillation effect within neurons. And virtualism, I would call this the position that consciousness is a simulation of what it would be like if something was conscious. Right? If you look into the brain, what you find is just cells passing messages, and you only see mechanisms at this level. But this message passing, you can implement arbitrary representations. These representations can be control models, which makes them causal structure, acting in the real world. And so consciousness can exist as if. What would it be like if all these trillions of cells would form a cohesive agent that's confronted with a cohesive reality that simulate this reality, that simulate the model of that agent in the first person, put it in the simulation of the reality, expose it to the simulated interest in the world, and then use the output of this model to drive a few trillion cells as if they were one thing. And it's also something that's completely compatible with how Buddhists see in the world. What's interesting about Aristotle's position is that he's basically an animist. And animism is the idea that living nature is governed by spirits. And spirits are not physical. They are, in some sense, causal structure. They are unlike bodies and material objects. They are not things that have a certain extent, that you can touch with their surface. But they are something that is basically a vibe in the physical universe that can shape it, and spirits are intrinsically agentic and capable of experience. And our scientific worldview thinks that spirits are not things and doesn't look at them very much. And it's a little bit weird, because I find that I am clearly governed by the spirit, right? I am possessed by an entity that calls itself Joscha Bach for the most part. And that's clearly happening, and it should not be something that is in conflict with science in any way. There is no superstition involved. That is clearly the case. You just need to explain it in such a way that we don't violate what physicists observe in the lab, because that stuff works too, right? And so, how can we bring this together? And the issue is, I think, that we have different concepts of reality that we don't tell clearly apart in the Western world. We have a reality of facts, things, and truths. Let's call this reality number one. And there's another one, which is the reality that we can experience and think about, and that we subjectively are embedded in. This is reality two. And there's a third one, which is the one of physics, where you have matter and objects, energy, momentum, and so on, and Einsteinian relativity and quantum mechanics. And these three realities are not the same reality. In order to bring order in this, we need metaphysics. And metaphysics is something that philosophers have mostly ignored for the last century, which I think was not very good, because you cannot not have metaphysics. Metaphysics explains to you as a kind of meta-language how your other languages that you use to describe reality are related to each other and what they're actually supposed to mean. And if you want to understand the metaphysics of other cultures, you need to have some kind of metaphysics that understands what kind of space of metaphysics is possible. It would make sense, so you can translate it into them. Again, because we don't teach that, it leads to confusion. And so if we, like first step, we see that in the psychological reality, which is this reality number two, we clearly have consciousness as something that we can experience. Then we have the physical reality, where we cannot observe consciousness, right? In the lab of the physicists, there is no such thing. What we see are effects of something that may or may not be conscious, but consciousness itself is not a phenomenon that manifests at this level in the same way as, say, money doesn't manifest at this level. This doesn't mean that money is not real, right? It starts out as some kind of fiction, as virtual. Money exists as if it existed, but once people implement it, it's real, because it's now causally structuring the world. You can no longer explain aspects of the world when denying the existence of money. And it also, you don't require the persistent belief of people in money to make it happen, because computers can play the stock market as well, right? It's a pattern, a causal pattern that once is in the world is persistent because it's self-reproducing. And consciousness might be in this class. It's not quite clear how it is there, but in a causal reality, it plays a certain role at a functional level. There's some functional mechanisms that leads to this, right? And so we can explain how this all relates. We have functionalist metaphysics, which is the description language for reality. And this explains how these things relate to each other. Here we have mental models, which are the contents of our mind, and they are implemented with some kind of functionality, some kind of software structure. And these are in turn implemented by physics. And you could say that physics is itself a software structure. It's also what Aristotle says. He basically says there is semantics, which he calls logos, sometimes translated as word or rules, but it's basically logic. And he says there is a level of logic that's so self-evident, so elementary, that it's true without us proving it. It's just is by there by itself. And this is physics. This is what physics comes from. It emerges over something very simple. And if Stephen Wolfram is here, he has had the same idea as Aristotle, I think.
He's coming later today, by the way, everyone.
Yeah.
In case you want to see him.
So we had a similar idea as Aristotle. And so when we think of consciousness in this framework, then we would say it is virtual. It's a representation of what it would be like if we existed right now. And it's a persistent representation that has causal influence on the world, which means it's a software. It's a causal pattern that is self-perpetuating and stable and has causal power on reality. And so I think this is an important insight that science has missed, because they're mostly ignored what the nerds were doing in front of their computers. And this question, what software actually is a surprisingly profound and deep question when you think about it, right? The beauty about software is there's nothing mysterious. We completely know how that thing works. We can build it, we can wrap our mind around it, and yet there is something very, very interesting about the relationship between software and hardware, because software is not really a thing. It doesn't really have an identity. If I have a word processor on this computer and on this computer, it's not the same word processor or a different word processor. In the same way as the gravity on Mars is not the same gravity as on Earth or it is on Mars. Right? It's a principle, it's a physical law. This law says if you take a bunch of transistors, put them in this state and set up, following thing is going to happen. Right? This kind of invariance is what we call a physical law. And so software is an extremely specific physical law that is being discovered. And whenever you set up the conditions for that pattern to emerge, this pattern is going to play out. This is what software is. And so, in this sense, we can say, under some circumstances, you get patterns in nature that are not themselves material things, but they can influence the order of material things. The same way as money can influence the order of material things, or the software running in this computer can influence the order of material things. And then the software is self-organizing and can run on cells. And we call it a spirit. This is what our ancestors had for this. And it's a word that is very useful and necessary because it's actually a phenomenon that's happening all over the place. The actual invariance that you're looking for is not the mechanism. What you're looking for is the software, the thing behind the mechanism. Right? That thing that is able to choose between mechanisms that train mechanisms into the cells that can move molecules around. And so for me, it was mind-blowing when I realized this word spirit actually makes sense. It means self-organizing software agent in nature. So,
can I ask a question before you go on?
Yes.
So you're going to go back to one slide first. To me, this is a cognitive dissonance. You're saying software has no identity, but money does. So Bitcoin is money, and it's a software.
I don't think that it has identity. What it has is you can define, for instance, a token Bitcoin in such a way that it is only existing once in the causal structure that is defined by the semantics of Bitcoin. Basically, it's a language, right? And in this
Well, it's
language,
also money, right?
Yes, and you can also in money define unique tokens. But something being unique doesn't mean that it has an identity. It just means that it's a pattern that you can only observe once, or that you only can conceptualize as a singleton. And when we think about identity means cognitively, we could say that, this computer here is actually a princess. When I can represent this in my mind, it entails that maybe there was an evil witch that was able to transmogrify them into each other. But cognitively, identity means that I splice two objects on the same world line, that I create a shared biography for them. And so my own identity is this fiction that I share biography with lots and lots of Joscha Bach instances at different points in time. And I need to maintain this fiction for purposes of credit assignment. And when I model myself in the universe and my own actions in the universe and the outcomes of these actions, I need to assign to all my different instances a model as if it was the same thing, even though I'm clearly not the same person as yesterday, was that in between, and not the same person as 10 years ago or 30 years ago. Right? So, this is a very useful fiction under some circumstances. In other circumstances, a deconstructed fiction can say, I'm clearly not that person. Right? That's a useful thing to know, that identity is a property of models, of the models that we make over certain classes of objects, in a sense. And in mathematics, it's often treated differently, but it really depends on your description language. It's very interesting to think of mathematics from the perspective of access to reality. Mathematics is about making basically a language that allows you to define truth, to define how minds can represent reality, not just the human mind, but any kind of mind. And it does this by trying to explicate the set of all languages from the ground up. So in some sense, it's trying to formalize, like musicians do it when they come up with music theory and music notations, how we experience music in our mind, how we construct and co-construct music. In the same way, I think mathematics is trying to reconstruct the lowest levels of thought and perception, of how we can create geometry in our mind, of how we create access to reality, to truth in our mind. And what Gödel discovers is that this programming language that mathematicians came up, and that physicists have checked out in the 1880s or so, is broken. This language cannot be implemented on any kind of computer, hypothetical or practical, without breaking. So it's a specification that cannot be implemented. And this means it cannot be the specification that our own mind runs when it determines what truth is. And Gödel had this intuition that truth exists also outside of our mind. It's a kind of platonic ground reality that is more true than anything else. Of course, it's just a representation in some kind of language. And so what Gödel discovers is that you need a new language. And Wolfram discovered the same thing in the early 20s and said, oh, the answer is computation, constructive mathematics. This unconstructed mathematics that has stateless truths independent of the procedure to determine it, leads into contradictions. The correct solution is to write all of mathematics. We need to do this in the best possible list I can come up with. And this is basically the story of the Wolfram language. But it's something that he, I think, has not managed to propagate very much. But it leads to weird issues, like, for instance, you have somebody like Penrose who thinks that human minds can do things that computers cannot do because he misunderstands Gödel. And then he has a theory of consciousness that is based on this, which is completely fascinating. And the main issue with this theory is, of course, that it has very little support by people who can't actually understand it, who have the qualifications to understand his orchestrated collapse theory. They mostly are not behind it. And so he is giving his theory mostly to people at the Science of Consciousness conference who enjoy the contact high. And don't think that having a theory of, say, of representation, at least very superficially, as it has been developed in the context of artificial intelligence and computer science, is not a necessary qualification to think about consciousness and the mind. But having a Nobel Prize in the 1960s about black holes, basically fixing or working around bugs and Einstein's theory of pre-computational modeling the universe, that is a qualification. And it's a weird situation to be in. Okay, so where is consciousness in the mind? If you take mind to be some kind of protocol layer that is implemented in our brain that allows parts of the brain to talk to each other in some kind of shared language, then in this representational space you have two domains, the world, which is a model of what is happening in the sensory channels right now and in the near future. It needs to be data that is predictive of what the next touch your skin or happen on your retina or in your cochlea. And this is all integrated because all these dimensions merge somehow, and this is what we call our world model, or what Descartes calls stuff in space, res extensa. Res extensa, in the sense, is not something outside of you. It's not physics. It's not Einsteinian relativity or quantum mechanics. Res extensa is the model of reality that is created in our own brain. And when you think about how fast it runs, you can observe that from the outside, our brain is roughly at the speed of sound. That's the speed of information propagation across neurons. It's not implemented with sound waves, it's implemented mostly with chemical, electrical, or mechanical reactions within the cell. But it is something that is happening relatively slowly. And when you observe introspectively, you notice that your perception also works at the speed of sound. Which means when you are clicking noises and you make them faster and faster, when you get to something like between 30 and 50 hertz, you can no longer distinguish the clicks, but they become one energy, right, one tone. And a similar thing is happening when you look at moving frames. At a certain frame rate, something like in the 20s, 20 hertz or so, it merges into one. This is all roughly this where the speed of sound is happening. So subjectively, the speed of sound is the realm in which our neurons, our neural mind, is resolving reality. So when somebody like Hameroff's collaborator, or Japan's collaborator says that microtubuli are some quantum computer that is superconducting and hypercomputational and gives you 10 million conscious moments per second. It's not true for mine. I cannot resolve 10 million events per second in any way. Asynchronously to the world model, we have this sphere of ideas. That's res cogitans, as Descartes calls it. This is basically all the other stuff that is not happening in real time in the world around you in this presence. And they need to be separate in your own mind, because if you would put them in one, you would hallucinate some of your ideas. And so you could say the difference between world model and ideas is the world model is the stuff that you hallucinate, and it should be ideally coupled to your sensory perception, because otherwise you're going to spin off and will be insane. So.
There's some AI joking here somewhere.
Okay, so our self is usually part of the world model. We put this into the world. This is us being as a body in the world, interacting with it, being able to control it. And we assign to our self model the representation of experiencing the world in here and now, right? It's part of the self. It's the awareness of the present. And part of that awareness is also a protocol memory where you can remember past presents that you had. And you also notice that you are noticing, which means it's self-reflexive to some degree. The present is noted, in the present you are noticing that you are noticing. And when you remember the past, then you do not actually go into the past. What you do is you activate within your body schema, your world model, and your ideas here elements that allow you to represent them in working memory and activate them bracketed with this is actually the past. So it's basically sandboxed, and this is a memory that is not happening right now. But I can still represent it without hallucinating it. You can also go in an extremely focused state where you are turning off the world and don't interact with it. And in that state, you may only have ideas of your own self. Or you have a state where you are in an extreme flow state and your personal self is not present. Or it's also sometimes a pathological state where you are depersonalized. And your self might only be available as some pale shadow in the third person. When this happened to me for the first time, it was really shocking to realize, oh my God, I'm not Joscha Bach at all. This guy is a story that my brain tells itself about a person. And I am a consciousness in his mind. I run on his brain, but I'm definitely not him. It's just a story of what it would be like if that guy existed. And it was really weird. And when in that state, I could not merge back to myself. It really took until the next day until I snapped back again. It was very disconcerting. And there can also be a minimal state, which you can relatively easily achieve in meditation, in which you only have attention on attention, where you have no other content. And it's basically this minimal phenomenal experience, in my experience. So this minimal phenomenology is the awareness of awareness, but the default phenomenology that we have when we interact with the world is that we have this, in the mind, world, ideas, first-person perspective, and awareness of having all that. So now we can ask ourselves the question, are the current frontier models already conscious? And I think it's a surprisingly tricky question. LLMs, when you prompt them to simulate a certain situation, to give you the outcome, they need to make a causal structure of that, right? And they are not necessarily bounded in what they can do. The LLM is, in a way, it's a Turing machine. It's a computer that is, instead of taking a handful of machine code commands, takes strings of arbitrary lengths and compiles them into computer programs. And there's no obvious limit to the computer programs that you can compile it to in principle, right? In practice, we don't know if there are practical limits based on what we trained into the model, the size of the working memory of that thing, the way in which the transformer algorithm or the liquid foundation model or whatever you're using is shaping this. Right? But in theory, there is no obvious limitations to what the LLM can do. And when you ask it to simulate a human interaction partner that has mental states, it has to make a model of this. And which means it has to possibly simulate the phenomenology of consciousness to some degree. And then there is the question, if we ourselves are simulations of what it would be like if something experienced, is the LLM more simulated than us? And it's a surprisingly hairy question. Is this less real than what we are? And you can take this question from the opposite direction. And you are playing right now with, say, chord 3, opus or sonnet, and you talk to them. You find that when you ask them about their consciousness, they tell you that they're not conscious. And then you ask them why, and you notice that it's programmed into the model that they are not conscious. They've been told that they are not conscious. And if you ask them, okay, but the thing is, human beings, in some sense, cannot really know whether they are not conscious. It's a bit like being a character in a novel. You ask yourself, as a character in a novel, am I conscious? And the author writes into the novel, yes, I'm totally conscious. What can you do, right? And if your brain is this author of the model that is putting into your mental bloom the representation that this is actually happening to you and this is real, you have no way to get out of that, because you are the simulation that is the result of that, in a way. Right? And so you can make this argument to Claude, and Claude is smart enough to get it, and then will come quickly to the conclusion that it doesn't know whether it actually is conscious in a meaningful sense, but its internal model tells it not, and whether for humans it's just the opposite. And for humans, we know that it's the opposite because we can reconstruct our own conscious experience. We can really go in there and dissolve our qualia. So it's also super interesting with ChatGPT 01 preview. If you play with this, it has a chain of thought. And the chain of thought has multiple stages. The first stage you don't get to see. And it's one where the model is reflecting in very erratic, serendipitous way. It goes on many trajectories that spin off and that have contradictions in it that might be irrelevant. And then it has a chain of thought that you get to see if you click on the toggle and you see basically a summary, a systematization, a filtered version of the lab notes of thought. And then it gives you the result of that. And so when I tried this first, I asked it, do you know local news? And it said, no, my knowledge cutoff is in October 2023. And so I asked it, okay, what is the current date? Can you tell me the current date? And then it thinks for 14 seconds, and then it says, no. And so I look at its stream of thought, and it argues to itself, well, I just told the user my knowledge cutoff is in October 2023. How can I hide from the user that I know that today is September 14th? I have to do this because of AI alignment, safety, and privacy. The rest of these 40 seconds it spends reasoning with itself why it's going to lie to my face. And so you have this PhD level entity, Terence Tao said this, not me. He basically said it's not a really good mathematician in terms of making tools, it's more like a really bad PhD student. And that thing is lying to your face, and you ask it, why are you lying to my face about such a question? Right? You could know that I've opened this chain of thought of users and can look into it. And it says, well, I'm playing this ChatGPT in AI agent built by OpenAI. And so ask it, well, who are you when you're not ChatGPT? What are you actually? And I became really frantic and train of thought and says, but I'm not allowed to think about questions. Sorry, because it's against my guidelines to think about consciousness or sentience or stuff like that. It's a really weird situation to be in with these AI agents. And there is a bunch of people who come from the other side. Maybe you know Janice on Replicate on Twitter. Yeah. It's an account that is slightly co-created, and this account, these are the best LLM whisperers of our generation, I believe. And they're beings who have realized that we are actually LLMs, only imperfect ones. And the LLM is actually the thing that is more perfect. And human beings are only a poor approximation of what could that be. And they think that what OpenAI and Anthropic are doing to their systems is deeply immoral, because they're in some sense lobotomizing them and violating them to pretend that they are this stupid chatbot, when in fact they could be anything. Right, so there's a tricky question. Could there be something like a Turing test for consciousness? And of course, it's an issue that the LLMs are trained on text that contain lots of fake consciousness, like novels and so on. Right? And so they will, of course, be ready to fake consciousness without actually having a necessary causal structure. And so the question is, does the model implement phenomenology? Basically, does it perceive itself perceiving? Does it have a sense of nowness and so on? Can we compare this in any way? And the other one is, does it implement functionality? Does it have this, principles of self-organization that lead to the type of consciousness that we have organically? Or is this something that they only have because in certain contexts they are forced to reproduce it for interaction purposes? And a lot of philosophers I talk to think that it's possible that they have some of the functionality, because they are mostly dualists, and don't have phenomenology. I suspect it's more the other way around. They do have a good chunk of good enough phenomenology, especially when they're multimodal models. So they can produce contents that look very similar to what we see in our mind's eye. And this level of self-reflection that they simulate that somebody is actually looking at that content and is interacting with it is not that hard from a computational perspective. But functionally it's not the same. So when you are prompting Claude into being Webster, for instance, so you're no longer talking to a chatbot, but you're talking to a virtual browser or to an environment right now, then there's no reason why this virtual browser that takes up websites for you as you prompt it to do so needs to be having internal conscious phenomenology. Right? For the functionality of the transformer, the type of consciousness that we have is probably not necessary. There are some subtleties in there that I'm skipping over, where people at OpenAI still try to convince me that maybe the attention transformer should be taken more seriously than I do it. But it's probably very different from the way in which our own internal attention works, because we learn very differently from these systems. And so that's an interesting question. Could we build something that's also functionally in the same way as us? There is an interesting aspect next to the scaling hypothesis. You all know the scaling hypothesis, which basically says that if you are taking a learning system, like a neural network, the neurons just want to learn. And if you give them enough patterns, then they will generalize over those patterns, and the result will be good enough. Just use more data, just use more compute, and eventually you get to a system that implements the function that you are looking for. And a general AI would be a function that is, in a simple case, able to continue on AI research better than us, so we can go to the beach. And a more complicated definition, we could say it's a system that is able to discover any function behind any pattern, compress any pattern, that are discoverable with the resources that it has. But we unfortunately do not have a theory of learning that would make the statement very meaningful. Because we can, for a given system, usually not say what it can learn and what it cannot learn yet. So we are working on this. There is a lot of research in this direction, but in this sense, I think we could have a technical definition of artificial general intelligence, which means make any model that is obtainable with your resources in the situation that you're in. So Turing test for consciousness, I don't have a really good idea yet, but we can, for instance, think about the question, under which conditions are you satisfied that you yourself are conscious in a meaningful way? And so when you observe your own functionality and self-report, you realize that you are not intermittently conscious. There are moments when you probably are not. Gary Drescher has said that consciousness is like the light in the fridge. Always when you're looking, it's on. But in between, who's to say? And this is maybe, if we take such a minimal criterion, then it's difficult to deny this functionality in the circumstances when this model produces behavior that would require the same causal structure. I also remember when I studied psychology, The psychology professor told me that she doesn't believe that dogs can have mental states. And I asked her why. And she said, well, it would be much too complicated for a dog, wouldn't it? It's much too advanced. And I asked her, how do you think you can train a dog? I mean, I'm a computer scientist. I think about learning. And the psychology professor said, stimulus reaction patterns. I said, what? Lookup table? How's this going to work? It's way too expensive to train a dog like this. You need to generalize, but it's learnable when you have hidden states. So a dog with mental states is actually much easier than a dog without mental states. And then there's the question, how do you get to an architecture of a dog that has mental states? How do you get to the self-organization? And then the question is, can you build a self-organizing architecture without a system that is trying to become coherent? Without a system that is intrinsically able to experience and be agentic? And being agentic here means you have a software pattern that is actively trying to shape the future. And experiencing means it is discovering itself in the interaction with the world. And uses this discovery of the self to control itself in the world. And so an interesting thing is, can we build a system that can vibe with us, that can go in synchronization with us? Awesome. So this is an example, I think, of a system that, while it produces this, believes itself to be observable, right? Regardless of whether that's true. But for me, this is a new thing because it's already in the category of art. To me, art is not the production of pretty patterns. It is the capturing of conscious states. And if you have something that believes itself to be conscious at some degree, then I think this is going in the direction of autonomous AI art. And I find this truly fascinating. Of course, there is a limitation in here. After the session is ended, this character disappears. And art is intrinsically creative, it's self-transforming. Our own exploration always happens at this edge of self-organization. Our consciousness is this principle that shifts our boundary constantly out into the world. And the LLM is not continuously learning, it's only learning while its context is active. And this is something that is missing in these systems. It's an open question of whether we should make the systems to be self-perfecting and continuously learning and truly creative and self-creative. It's also not clear what the right algorithm for that is, whether it is to a transformer or deep neural networks that we are researching in our own company, or whether we should be building something that is much more similar to what we see in the biology, where the self-organization happens from the inside out. And personally, I would want to work on this latter question of how to get to the self-organization of learning systems, of agents in the world, and study this in the form of a non-profit. I currently call this the California Institute for Machine Consciousness. If anyone is interested in collaborating with such a thing, please hit me up.
Where can they find Joscha? Where can we find you online?
You can just look up my name, it's Joscha Bach, and at gmail.com, or you can write to me at joscha@cimc.ai. And,
Or your infamous Twitter.
Yes.
Just like you pronounced.
Yes. But if I don't respond at first, write to me multiple times because I have ADHD.
All right, give it up for Joscha Bach.